We're now at the top of page 75, and we'll pick up where we left off. We'll go over these a little more slowly because they're equations that have all letters in them. We still solve them exactly the same way, though. This tells us what we're trying to get by itself, so we want r by itself. A good idea anytime you have a fraction is to first multiply by the denominator of that fraction so that we get rid of it. So this says divide by 2 in that fraction, so I'm going to multiply by 2. On the left-hand side, s times 2 is 2s. On the right-hand side, that leaves me with r plus p. Now remember, I want r by itself, so we don't want to touch r, we want to move everything else away from r. So we have plus p, the opposite of that is minus p. On the left-hand side, we want to write that in the order we see it. We see 2s minus p, so we're going to write 2s minus p. On the right-hand side, that leaves r by itself, and that's our answer. You could switch the sides if you want. R is equal to 2s minus p. So here's another example. We want k by itself. So again, we have a fraction. Let's start by getting rid of that. It says divided by t, so let's multiply by t. So on the left-hand side, s times t, we can just write as st. On the right-hand side, that leaves 3k. Now if I want k by itself, I need to get rid of that 3. That's really 3 times k, so we'll divide by 3. On the left-hand side, we just copy what we see. S times t over 3 equals k. Again, you can switch sides if that makes you more comfortable in the end. So in this example, we want r by itself. So we want to move other things away. So let's start with that 1. It's a positive 1 right now because there's nothing in front of it, so we'll subtract 1. So we get q minus 1 is equal to, don't lose the negative in front of the r, plus t. So we have plus t. We're still trying to get r by itself, so leave the r alone and move everything else away from it. So we want plus t. We're going to subtract t. Again, write the left-hand side in the order you see it. We see q minus 1 first and then minus t. And over here we still have a negative r. Now we don't want that negative there. We want to change that sign. We want to make it opposite. If we change that sign, if we make it opposite, then we have to do the same for everything that's on the left-hand side. So that would give us a negative q plus 1 plus t equals r. So this changed from positive to negative, this changed from negative to positive, this changed from negative to positive. And that's my answer. So here we want h by itself. So we're going to start by leaving the h alone and move the other things away from it. So we'll add ab to both sides. And we'll read the left in the order we see it. V plus ab equals r squared h. Now I still want this h by itself, and it's r squared times h. So the opposite operation would be division. So I'll divide both sides by r squared. That leaves me with h on the right, and on the left we'll have v plus ab over r squared. Okay, this one's a little bit different. So in the bottom we have a minus b, and I told you that quite often the best way to get started on these problems is to multiply by whatever that denominator is. And that's true for this as well, but we need to put it in parentheses. So I'm going to multiply by a minus b on the right and multiply by a minus b on the left. So I have p times a minus b equals t. So I'm trying to get a by itself, and right now I have p times a minus b. So now we can get rid of the parentheses. We can take p times a and then p times b. And then I still want this a, so I'm going to leave it there. I'm going to move the things that don't have an a away from it. So now I have PA equals T plus PB. And then finally, if I want A by itself, I can divide by the P that's in front of it. And when you divide, it has to be the whole side. So we get A equals T plus PB over P. You can't cancel out those P's because the P on top is part of an addition problem. So let's look at example 13. We want A by itself, so we're going to start by moving the other piece. We'll start by subtracting 2B. So again, on the left, we want to write, in order we see it, P minus 2B, and that leaves 2A. So now we're going to divide the right-hand side by 2 in order to get A by itself. And if we do that, we divide the whole left side by 2 as well. Now we can't cancel those 2's out because it's part of a subtraction problem on top. It works the same as the end of example 12. We'll skip example 14 and we'll do this last example here, example 15. So we want to get A by itself. We have a fraction here, so the first thing we'll do is put that denominator in parentheses and multiply by the whole thing all at once on both sides. So on the left, that gives me S times 1 minus R equals A minus RT. Now I'm trying to get A by itself, so I see that I have this minus RT over here, so I just add RT. Now you can distribute the S if you want to, but you don't have to. If we did, we'd have S times 1 is S. S times negative R is negative RS or SR. And then plus RT equals A. A is by itself, so we're finished.